So in this chapter we will study about the trigonometrical transformation and its expansion, because it is necessary to know about this because there is a great deal of use in calculus. So we will know about this. The expansion of sin x is like this: x minus x cube by factorial 3 plus x power 5 by factorial 5 and so on. Similarly, expansion of cos x is 1 minus x square by factorial 2 plus x power 4 by factorial 6. And so on. Similarly, 10x have expansion x minus x square by x minus x cube by factorial 3. No, there is no factorial 3, just only 3, and 2x plus 5, 2x raised to 5 by 15 plus so on. That is minus plus minus minus plus minus, here minus plus, here should be minus. There is alternation of the minus plus. So these three are very important. You should remember the expansion of these three because they will use in solving the problem related with the differentiation. If you will differentiate this, then you will find this formula. Means very clearly, if you differentiate this, then you will find this formula, because ddx of sin is cos x, and this 1, and this will be 3 x square. So 3 and 3 will cancel, so there will be factorial 2, because factorial 3 is expansion of factorial 3 is 3 into 2 into 1. So if there is 3x square, so 3 will cancel, so 2 and 1 will only as a rest, so 2 and 1 will be factorial 2. Similarly here, if you will differentiate this, then you will find 1 by factorial 5 and 1 by factorial 5 and 5x square. So 5 will cancel, so there will be 4 3 2 1, that is factorial 4. So here should be factorial 4, not 6. You should be very careful that here should be factorial 4, that is cos x will be equal to 1 minus x square by factorial 2 plus x square by factorial 4 minus and so on. So that's all about this. And this is like this. Now see again. So just I have shown you that here should be x bar 4 by factorial 4. Now moving to the next. The fourth formula is tan inverse x plus tan inverse y will be like this: tan inverse x plus y by 1 minus xy, and this will be like this: tan inverse x minus y by 1 plus xy. Similarly, sixth formula will be 2 tan inverse x, that is equal to tan inverse 2x by 1 plus x square. Sorry, this will be 1 minus x square, tan inverse 2x by 1 minus x square. And sin inverse x will be sin inverse x plus minus sin inverse y will be equal to sin inverse x 1 minus y square in under root plus minus y in under root 1 minus x square. And the next formula is cos inverse plus minus cos inverse x plus minus cos inverse y will be equal to cos inverse in bracket xy minus plus. That is the important. Here is plus minus, here will be minus plus. That means if here is plus, so that will be minus, and if there is minus, so there here will be plus. So formula is like this. So these are the very important formula. You should remember these formula because there is a wide use of application. Sorry, there is wide use of this formula in the calculus. So here you are saying the just reciprocal. Sin inverse x will be equal to cosec inverse 1 by x, and tan inverse x will be cot inverse 1 by x, and sec inverse will be equal to cos inverse 1 by x. Sin inverse sin x will be x. So these are the formula. You have to just memorize, remember, or keep in the mind, because there is a huge so cos inverse cos x will be x, and tan inverse tan x will be x. Now looking at some another formula, that sin inverse cos x can be written as a sin inverse, and cos x can be written as a sin pi by 2 minus x. So sin inverse sin x, assume this is whole as x. So the sin inverse sin x will be pi by 2 minus 6. Cos inverse sin x will be cos inverse cos pi by 2 minus x. So cos inverse cos x will be pi by 2 minus x. So tan inverse cot x will be tan inverse cot x can be written as a pi by 2 tan inverse, sorry, tan pi by 2 minus x. So that it will be pi by 2 minus x, because tan inverse tan x is x. So here x is, suppose that pi by 2 minus x, pi by 2 minus x. Just use this formula. Use of this formula is here. So in this chapter mainly we have seen the numbers of the formulas. Important trigonometric result. 1 minus cos x plus 1 plus cos x will be equal to, this can be written as a 2 sin square x by 2, and this can be written as 2 cos square x by 2. So finally this will be written as tan inverse x by 2. Similarly 1 plus cos x 1 minus cos x, this can be written as 2 cos square x by 2 and 2 sin square x by 2. Note how can this is written, do you know? This, because cos 2x is 2 cos square x minus n. So cos x will be 2 cos square x by 2 minus 1. Similarly cos x is also 1 minus 2 sin square x by 2. So here if you write the 1 we cancel and final this. So finally cot square x by 2. You should just keep in the mind, because you have to use this in frequent, because in the question it will come as a step, and if you don't know then you will solve it and you will take time. So you have to keep this result in mind. So cos 2x is 2 cos square x minus 1, cos 2x is 1 minus 2 sin square x, and similarly cos 2x is, similarly cos x is 2 cos square x by 2 minus 1. So here see that if an angle is 2x, then here is being x. When angle is 2x, then here is being x. So we have, when angle is 1x, so that will become x by 2, and so on. 1 minus 2 sin square x by 2. So 1 minus cos x can be written as 2 sin square x by 2, and sin x can be written as 2 sin x by 2 into cos x by 2. So this can be sin square, this is square, and this sin x will be cancelled, 2 to cancel, so 10 x by 2 will be finally. And 1 plus cos x by sin x can be written as like this, 2 cos square x by 2. into sin x by 2 into cos x by 2. So after solving you will get cot x by 2. This can be written as a like this. This one can be written as sin square x by 2 plus cos square x by 2 plus cos square x by 2, and plus minus sin x can be broken as a 2 sin x by 2 into cos x by 2, plus minus 2 sin x by 2 into cos x by 2. So this is now looking as a square plus b square plus 2ab, or a square plus b square minus 2ab. So you can write as this as a plus minus b whole square. So a is sin x and b is cos x. So you can write sin x plus minus cos x, sin x by 2 plus minus cos x by 2, x by 2 plus minus cos x by 2 as a whole square. Sorry, this is whole square and this is 1 by 2. So this will be cancelled. So finally will be written sin x by 2 plus minus cos x by 2. So that means to tell you that if there is such expression, then you can write like this. Tan a plus minus tan b can be written as a sin a by cos a plus minus sin b by cos b. So by cross multiplication, this can be written as sin a into cos b plus minus sin b into cos a. So this can be written as cos a into cos b. So this can be written as sin a plus minus b. This is sin a plus minus b form by cos a into cos b. So this can be also written as like this. Now we will see so this is tan pi by 4 plus theta. So in short form it is written as 1 plus tan theta by 1 minus tan theta. And if you want to write it in broadcast form, then you will write is you will expand is just like a tan a plus b. So tan pi by 4 plus tan theta by 1 minus tan pi by 4 into tan theta, which will give 1 plus tan theta by 1 minus tan theta. Just see it. I am expanding. I am expanding it, just treating like a plus b. One plus tan theta, 1 minus tan theta. Very important relation. Similarly, here will for minus, here will be minus, and here will be plus. So sin x is 2 tan x by 2, 2 tan x by 2 plus 1 plus tan square x by 2, and cos x is 1 minus tan square x by 2 by 1 plus tan square x by 2. If there is a cos 2x, then you will write 1 minus tan square x by 1 plus tan square x. Note, don't make confusion with tan pi by 4x. With the expansion of tan pi by 4 plus x is 1 plus tan x by 1 minus tan x, and tan pi by 4 minus x is 1 minus tan x by 1 plus tan x. So in tan pi by 4 plus minus x, there is no terms involving x square. There is only tan x by 2 and tan x by 2. Such a concept term will be used, but not square. But in cos x, there will be square term will be used. Just see it yourself. Write down the formula of tan pi by 4 plus minus x. Then you will see the result yourself. Or for the better result, write down tan pi by 4 plus minus x by 2. In place of x, write x by 2. So you will see the more closer result to this. Just write down and check yourself. So sin 3x formula is 3 sin x minus 4 sin cube x, which is very important formula. Cos 3x is 4 cos cube x minus 3 cos x. This is also important. So these are the important formula which is generally used in solving the question. So I have discussed all the formulas in the writing mode. Substitution for differentiation. So now we have used I have write every formulas and tactics. So now we'll see the some substitution for differentiation of algebraic function. If there is a square minus x square, then put x equal to a sin theta, a tan theta. If in such kind of the case, you will put x equal to a sin theta. Why? If you will put x equal to a sin theta, then it will give a square minus a square sin square theta, and take a square common, so that will be a square in bracket 1 minus sin square theta, so that will be a square cos square theta. So that when you will remove this under bracket, that is under root, then that will be a cos theta. Similarly, since you will put here, then you get a square plus a square tan theta, and 1 plus tan square. If you will take a square as a common, then you will find a square times 1 plus tan square theta, and 1 plus tan square theta is sec square theta. So you can easily find it. So that will be a sec theta if you will remove this bracket. Now x square minus a square, so put x equal to sec theta, a plus x, a minus x, put x equal to a cos 2 theta. Note: substitution are so chosen, means substitution are so chosen so as to get rid of radicals. This is called radicals. So we have to choose substitution such that we should get rid of radicals. Even if the power were 3 by 2 instead of 1 by 2, same substitution. Same substitution will work. So these are the very important substitution. This will highly used in the, as you will solve the differentiation problem. So if you are not sure why the such a kinds of assumption is taken, then you will put this, then you will know the importance of this assumption. So if you put this, then you will get a square comma a square common times in bracket sec square theta minus 1, so that will be tan square theta. So you have to remove this radical. So if you put that similarly a cos 2 theta, then after solving you will find 1 plus cos 2 theta by 1 minus cos 2 theta, which can be very easily solved. That will be finally cot theta. Just solve it and see yourself. So that's all about this. You were seeing the RSL study material. Just see more and more video and increase your more knowledge and remove unnecessary pressure that is produced by your teachers. So remove the stress and strain, bring the good marks in your school levels and crack the all competitive examination. So that's all about this. Carry on to see the video. Thanks.